Happy Thursday, everybody.
Happy Thursday.
Happy Thursday. Season 1, episode 21. 21 episodes, Nick.
Ooh, we're 21.
21. Well, I guess 20 if we take out the fact we took vacation on July 4th because it was July 4th.
Yes. Yeah. So I guess.
But 21 episodes.
Yeah.
Man.
That's good. I couldn't expect we get this far so quickly. So.
Well, and one thing I want to talk about before we bring our guest on, we got Explore coming up. I know you're doing some talks. What talks are you doing?
Oh boy.
Let's go through all 300 of them.
Yes. Yeah. So I had a link here. Mia sent me a link, and I need to find the link again. So there's some targeted agenda links. What we call them.
There we go.
There you go. Yeah. So those are some highlighted. If you're in the CF community per se, you probably would like those sessions at Explore. And let me refresh my screen here because I loaded that link and now it's doing nothing apparently. Good times. But so I guess we'll just I can walk through it without the visual reference. I've got a tutorial session on basically going from 0 to, let's say, hero on the GenAI tile or GenAI for Tanzu Platform. So you want to have a very deep dive kind of installation guide and how to use it type of thing. Well, the platform side, developer side. I'll have a 90-minute session on that. We have a lot of customer sessions. Nikki, I think you have some sessions that you might want to talk about.
Yep, absolutely. So I'll be doing a session with one of our financial services customers. So talking about how they were able to scale using tPCF, go from 0 to 125,000 plus AIs in the last couple of years. That'll be fun. It'll be a panel talk. Also doing a session with Corey Dinkins. We're going to be doing a 90-minute code session in which we're going to be telling you how you can create a public cloud-like experience on-prem. So going through both TP for K8s and TP for Cloud Foundry. And then we're going to have a Meet the Expert session where we're talking about Kubernetes, strangely enough.
Nice.
Yep.
And then I guess too to add a couple of things. So we've had our friend Deshaun on the podcast. I'm actually doing a couple of sessions with him about the sessions are entitled Spring AI Loves Gen AI for Tanzu Platform. So we'll be doing like the dev and the ops together in one story, I guess. And I think we have some hopefully a pretty cool demo to show that we haven't shown before anywhere. So that'll be cool. And then let's see here. I think the classic "What's New" with Tanzu Platform for Cloud
Absolutely.
Foundry.
A lot of good stuff coming
in. Join there. Some good things there we can't talk about yet, but if you can make it to that session, you'll see it first there live. So definitely check that out. But yeah, we had the link. There's a bunch of different sessions you should all check out and explore.
So and we'll go ahead and put this link down in the show notes after the episode. But if you're planning on going to Explore, go check out the link. Make sure that you pre-register. We were looking, a lot of these sessions, some of the seats are filling up pretty quick. So pre-registering is going to help guarantee you a seat. So make sure you pre-register for all of these. And got any questions, feel free to reach out to us on LinkedIn. Our LinkedIn is going to be in the show notes as well. So make sure you get up there. We're looking forward to talking. I'm going to have some, not only are we going to be doing these sessions that are live, but, we're both going to be talking to some customers that are there. And if you're going to be there, let us know. I'd love to meet up with you and talk. And are we doing a Cloud Foundry episode from there if we can?
I think we should. I think.
Are you going to have time?
I'll make time. Maybe we could revisit the Cloud Foundry After Dark.
Oh, we may have to because
do a late night episode or something. I don't know.
I know. We both got some stuff going on Thursday, so we'll have to get together and figure out when we're going to do this. But we'll see if we can do a better job than we did at Cloud Foundry Days in New York.
Yeah. Well, we're definitely not going to have the concept of the multiple AV competing with each other and that type of thing. So.
And one more thing, Speaking of Cloud Foundry Days, Cloud Foundry Day Europe, October 9th. So we're scheduled to be there.
We're on
We're do a live episode from there as well, pending everybody being able to work out travel, but we're hoping to see there. I know I've talked to, a couple customers that are over in Europe trying to get them to join. So Cloud Foundry Days is always fun. So if you're in Europe, October 9th, and I'm going to butcher this name, but Karlsruhe, Germany is where we're doing.
I think it's close enough.
Yeah.
It's better than what I would have said. So yeah, we'll go with that. And then definitely, if you're in that, if you're interested in that, get your tickets now, because we did sell out last year.
Yep.
So make sure you can get your tickets and don't have to worry about that for sure.
Yep. So on that note, we're bringing back somebody, friend of the show. He's been on with us several times. I think this is his third time on the show with us.
At least, I would say.
At least third, maybe four.
Yeah.
So Fynes, welcome back, brother. How you doing, man?
There, on the mute button. How's it going, guys?
Hey.
Fix to say, extreme close up on your forehead, right on.
Yeah, long time, not so much.
Man, I got to say, I appreciate it. Was fun the show that we did with Mia last week. Man, you guys were going nuts in chat about nothing that had to do with the show. We went all security on that show in the chat where we were talking ESG report on the show itself.
It was great. It was like a whole thread going on in parallel, right?
Yeah.
I hadn't seen that report. Mia took us all through, and it's magical. I love to see it, and it's always tricky when you implicitly know something, but for them to go off and do the research, get the numbers, and put them in, it's just great to see it proven out.
Well, and I think one of the things, we've gotten, there's comments that people think Cloud Foundry's old, right? It's not going to last. So, having something like the ESG report come out that still shows hard numbers coming from customers saying this is what they're experiencing using it, plus the fact that Broadcom's kind of doubling down on Cloud Foundry, it's the whole purpose of the show. Remind people Cloud Foundry's out there and in the good that it can do. So that ESG report, we'll make sure we post that up in the notes as well. But, definitely go check that out. There is a lot of good information. And, we only kind of scratched the surface of what the ESG report did with Mia.
Mm-hmm. Mm-hmm.
And then on your security, sideline that you guys were having in chat, I think we've got DMZs on next week, right? Yeah. So we're going to, security stories with DMZ. We're going to be talking about what, CrowdStrike's going to come up. We know it is.
Yeah. And look, the table stakes are just getting ever higher. Azure, I believe, had a DDoS attack this week after CrowdStrike. And I'm sorry, but there's no room for vulnerabilities lying around for years out in the wild. That just can't happen anymore. And that just plays right into getting yourself the right platform that's going to keep most of your house hygienic right out of the gates.
Yeah.
But I genuinely think that the table stakes for the security stuff, and CrowdStrike was an eye-opener. It wasn't an attack, but man, did it hurt.
Well, I mean, it was bad enough that they were having to come out and say, this is not a cyber attack, right? Oopsie, our bad, but, what are we saying? It was what they expected, Y2K to be.
Right.
We actually experienced the largest IT attack in history. So
8 million machines.
Or not attack, but largest IT interruption.
It goes back for me to that CF push being something people can spoof and fake. Like you can write a bash script to deploy something.
Right.
But for 1,000 developers all running concurrently with middleware that's all treadmill moving, right? You got to update your stacks, got to update your build packs. Your script ain't going to carry you that far. And it's not a day one comparison. Yeah.
Yep. Same thing goes. I mean, and then just the ability to, how do you patch some of these things? You can go through and patch them individually, or you can do them all at once.
Mm-hmm.
That's a superpower. That's a superpower of Cloud Foundry. You like what I did there, Mark?
Oh yeah, we're teeing up the title. Right.
I have been saying superpower, hidden superpower, and unknown superpower, and some of the stuff I'll show you guys today is stuff I've been in this for a while, and I'm finding out features in 2024, and some of them kind of snuck in under the radar and have been there for a little while, and it was really cool to kind of find them and say, hey, I got to share this with people. So I shared it with Josh Long on his show a couple weeks ago, and Nick said, hey, come on over and show us as well. And, again, it's great to find some excitement for things this does. That being in it for so long, I'm still finding new capabilities, which is great.
So you said for a while, how long have you been doing this? Because you're the reason I'm here, right? Let's be honest. You're one of the primary reasons that I get to do this job now.
I had a very interesting conversation, I'm going to say in 2013, and I was a partner. I was with a startup, and we were partnering with the vFabric folks. And they were doing this super cool project, and they were doing real-time telemetry on cell phones and helping the networks in Europe work really well. And I'm like, these guys are just having far too much fun. And I was tempted to jump over. And then I find out that they're working on this white-hot new thing called Cloud Foundry. And I think I joined, if I wasn't the day, I was within the week of it going live. GA was like the very beginning in January 2014, and I joined January 5th. And, I remember when it had one product manager and it was this new shiny thing. I remember telling people that it was very much for me looking back, walking around with one of these iPhones back into, 10 years ago with the amount of stuff it could do then. Remember, that's pre-Docker, pre-Kubernetes, pre-containers being in vogue, unless you talk to Solaris people.
Yeah.
And having looked back, and you know what? And the tech is transcended by the experience, right? They'll create experiences like this, but it is, in my opinion, the best gig when you can show teams how they can move as fast as they want, and all of the infrastructure stuff just gets taken care of for them, but not to a ticket. They actually have a control point. They can do stuff, and to this day, I think that's the magic.
Yeah, I agree, man. It's 2013. So you weren't far, 2009 is when Cloud Foundry was started. So yeah,
so they took,
isn't that right?
I thought it was 11.
So what happened was they got the guys to start working on something that would become Bosch.
Mm-hmm.
And VCAP is VMware Cloud Application Platform, which cracks me up. Like, it's gone full circle.
Right.
VCAP naming in there all the time.
Next rebrand.
VCAP.
Yeah.
Well, I think 2009. That's when Project B29 kicked off, right? Which I think was the precursor to Cloud Foundry. But I think the official release of Cloud Foundry was actually, you're right. It was 2011.
Right. And it didn't have build packs at the beginning. We want to talk about it at all there. V1, no build packs. I spoke to some of the OG folks, that predate me, customers, in fact, and they saw the V2 build pack model come along. I'm like, wow, this is great. It's funny though, I never thought of a Cloud Foundry before build packs. I'm always talking about them.
Yeah, that's awesome. Yeah. Well, we always talk, Bosch is one of those superpowers. The fact that this is the best platform for running Spring, it's the best platform for running .NET. I mean, what do you got for us, Mark? You're talking about new superpowers than the ones that we're talking about.
Yeah. So I'll drop my screen and we'll keep this going interactive. But I kind of got a little track I want to show you. Taking a little path through. We're going to push something basic, and then I'm going to show you a little secret trick the platform's got hiding in the wings to make it better. If that works. So let's see. Can I share screen? This one. And you guys seeing my screen?
Yes.
Yep.
Awesome. Okay, cool. All right. So, what happened a couple weeks ago, I kind of figured out how to do this in the last month. And I thought that I've been going back on native images and optimizing how you run in the platform, getting more bang for your buck, squeezing every ounce of compute out. Memory is always the precious thing. And I was looking at it, and I was using an external build system and creating a Docker image and then doing a CF Docker push a couple years ago. Nikki, I think you've been doing binary build pack native.
Yep.
But, we can do a nice demo. We can show it off. The real question, though, was, can that be taken to the next level? So I created this track, and, essentially just saying, we know it's the best place to run your Spring, and we know how good it is, but what's hiding in the wings? Like, is there new stuff in Spring that we can leverage to make it better? Because it's peanut butter and jelly, right? Your Spring app teams and your platform teams getting together and creating something magical. And so what I started looking at was, let me just push a base image, because I know my little anemic lab here in the basement's slow. So I'm going to just start it off and let this thing cook while I'm talking. But I got hello world here, right? It's going to print the index, and it's going to print the GUID as environment variables, but it's basically just going to go hello. And if I do a CF push of hello tPCF Weekly minus P target. All right. We all know the magic of CF push. In a couple of minutes, we'll have that going. What I will also do, because it will come up in a minute, is I'm going to create a loop that's going to keep calling that. So when it's up, we'll see it print. So that would be, if I just refresh here, and we got a route out of this guy, which is not live yet. That's fine. So I'm going to do a little while through, do sleep one, and curl this guy.
When you have a second, can you make some of your screens just a little bit bigger? Sometimes on the recording.
Yeah. How's that?
Yeah. Oh,
okay. So we're just going to leave a while loop going. So when that app stages, we'll just see it printing hello CF Weekly. All right. So that's our baseline. Now, first kind of call out on savings is we have a small footprint. Sometimes we forget that the platform can run in like as little as half a dozen VMs. And, you know, it's interesting. I'm going to come back to that once we see what I'm doing with this native stuff. And we get immutable infrastructure. We get fabric. We get spaces, logical environments to run our stuff in. So we're deploying. What are we getting in the box? And again, we'll go back to refreshing because there was a colleague of mine that said it, and I've brought it up on some of our weekly calls too. If you wanted to tell your auditor that you've got encryption going all the way to your container, and you're in the Kubernetes world, you're probably having to put a service mesh in there or manage certs right at the container boundary itself. Or you're going to get an exception and say, well, behind the ingress controller, it's inside the cluster, so we'll just look the other way. We have a service mesh in every single AI in the platform. Cloud Foundry built that in years ago, and it's using Envoy to do the terminating and cert rotating at that last mile right into those containers. And we take the pressure off the dev to manage certs and off the DevOps folks to set it up. And so beyond that service mesh, I have an image registry. It's just there because our droplets are going in. We're going to be looking at that in a minute. This is a really big one, a container build system. So we're running in the background here, hello Tanzu, on index 0 of that unique ID for that instance of the app. We didn't write a Docker file. We let the platform do it. And obviously, we can come along and restack our apps and rebase our apps so we can get those miners in for free. And then on the Spring side, they've been working on upgrade planners using Open Rewrite to help with the major upgrade semi-automated work. So we can keep current, like nowhere else. And secrets vaults, you know, it's not enough that you go install one, then you got to onboard all your clusters with a secrets vault with one baked in. I think that, Nikki, must have been our most popular service. Because the guys could encrypt any credentials for anything outside the platform and check the box saying it's protected, it's encrypted, and it's available to the app in the target platform. And we probably need another CF Weekly to go into the marketplace. It's there. But
and I just want to add, you know, I'm going to, forgive me, Mark, I want to add some stuff in as you talk.
Yeah,
but we've talked about this on the show before. I'm not going to name any names, but I love the way that you kind of showed this out because we're seeing with platforms that are coming up that are getting popular today, they're coming out and saying, hey, look at all of our new features. Yeah, we've been doing this for 10 years, guys, right? Not only are we been doing it, but we do it well. So, you know, I love the way that you package this because it really drives that message home. And I'm not saying that other platforms are bad. I'm just saying that we're better.
Yeah, I haven't gotten I haven't even gotten to the new stuff. This is the batteries included for quite a while. Like, I think we put service mesh tech in 17 or 18. Yeah. But I love the idea that the I own, you own, right? So no matter how well you emulate whatever you got here, it's not my headache below the business logic or any libraries that I need to bring that are part of what I'm deploying. But I can go Spring open source and go Spring commercial. I can go Cloud Foundry build pack. I can go into managed stacks. And if I'm just living up here as a dev or as a DevOps engineer, I get to push an awful lot of responsibility downstream, which is huge because it scales. It's one and done. All right, what's new?
And it allows the developers to do what developers do, which is develop, right? They don't have to remember all this other stuff. Anytime, wow, that's big yawn there, Nick. But
oh, sorry.
Oh, wait, you're not even on screen, so nobody could see that. I just called you out for no reason. But
yeah,
my bad. You can beat me later.
This movie before, it's all good.
But when every minute that you take developers away from doing what developers are paid to do, which is develop code, it's a loss of money. Let's be honest. So that's one of those things where if we keep developers doing code, the company's better for it, the app is better for it, the bottom line's better for it.
Exactly.
Here's my source code. Run it on the cloud for me. I do not care how.
Tell me what's old about that message and why it would ever go out of date, ever.
Yep.
So, first, what's new? What if you could shrink your app footprint? The one caveat is we always deployed with 1 GB RAM default. That was your accepted, sensible starting point. I would say, you guys keep me honest, somewhere in the 1 to 2 gigs average across all of the deployments we see, but certainly north of a gig for every Java app instance in the platform is pretty much normal. Now, I know we're in hello world. Excuse me, I'm not going to go much below 768 without messing with the heap configuration of the JVM. Remember, the platform is deploying this like a completely consummate professional Docker person, in the sense that there's a memory calculator in there that looks at the app, tries to look at the number of classes, and figures out an optimal slice of the pie to give to the heap and the metaspace. Like it's a sophisticated art to get to the level that's just given to us here, if we're manually cranking out containers and wiring up health checks. But then that brings up the question: do I really can I do something to make this more efficient? Because again, it's the most valuable commodity. I'll enter the Graal VM, guys. Now, I've been talking to Deshaun about this and getting super excited numerous iterations. And then I coupled it with chatting with Josh Long and seeing, as a platform person, like you say, Nikki, you almost want to be invisible to the team, to devs. You want to let them do, in quotes, their day job, give them full autonomy, let them in a guardrailed environment, virtual environment, just go at full speed. And you ask a dev, hey, have you considered Graal VM? And they'd be like, not my problem. I'm not going there. I'm not building a new, I can maybe get it to work on my laptop, but I'm not going to replace the build system. And I don't want to be the guy writing the Docker file and maintaining it that's going to start staging this kind of compilation effort. So what can we do? It's too complicated. It's a great demo. Here's the thesis. What if the platform could non-disruptively take what we've deployed? Now, we're in early stages. This is beta. This will work. But what if it non-disruptively come along and take that guy and natively compile it without going back to the dev teams, without asking for any external work to be done anywhere? All I had them do was -p native when they did the Maven package, and throw the where's my palm? And throw the build tools for Graal in their build plugins. That's it. They're not doing Graal compiling, but that small flag, which is invisible, doesn't change behavior, is all we've asked of them. That's what happened when I made the jar ahead of time. But that's a JIT compiled regular running app. Anyone old enough to know what that is?
Yeah.
The RAM doubler?
Man, you're showing your age, buddy.
Dad gave me a copy of the floppy. What can I say? No, just kidding.
Let me interrupt again, right? Because you're talking about, what if you could do a 90% memory reduction? So let's talk benefits before we get into why and how you do this. So what if we can reduce 90%, right? So that is something that we've been talking to customers about that are looking at capacity issues. Well, what if we did a 90% reduction of all your Java apps? What does that do to your capacity? Well, it's going to improve their capacity. However, when you talk to devs are like, well, I don't care about the infrastructure. I just want to push my code. I don't care that I'm using less RAM. Does it run different? Well, that's the other thing, right, Mark? Not only are you talking about 90% reduction in memory, but you're also talking about now taking these startup times to sub-millisecond levels, right? Something that may have took 1, 2, 5 seconds to start. Now we're starting in way less than a half a second. There's where you got to go talk to your devs and say, this is important to you for this reason. When you're looking at auto scaling and load stuff, the ability to start up your apps, faster than we can look is a huge advantage here. Mm-hmm. And maybe I'm jumping ahead of your demo.
No, you're spot on. And so the number of benefits that we see. So I think of this as a conversation starter. And if I can get 10 or 20% of your apps into a classification where they would be open to this, even though it's only 10 or 20% of your apps, I might take 90% of their overhead away. Mm-hmm. From a runtime footprint, kind of statically allocated amount of memory. I also, like you say, they might be much more amicable now to reactive scaling because the start times have just dropped to almost nothing. There's a ton of possibilities in there, that to the point that it doesn't need to work for even the majority of your workloads for this to be a very interesting thing, so long as the operational effort isn't too high. And that's where, while you were saying that, I said, okay, I ran a script, and I didn't use the jar. I gave it the name of the app. I'm in a new folder, and I just ran this little hack script I tied together to expose this platform capability. We'll go through it.
Can you blow that up a little bit as well? It's a little hard to read.
Sorry, yeah. So I just ran my little CF Java optimizer script on the app name that I'm targeting, okay?
Mm-hmm.
And what I did was I said, remember we said we got an image registry. We actually have an unstaged assets registry too. In the platform, when I run this, it actually asks the platform to give me back the jar that we deployed. And so I found you can use the CF API to log in, and you can use a CF curl, and you can pull back that jar that the dev team or the CI pipeline had deployed. Then what I do is I say, okay, I'm now going to push it again. But if I open another window and give us a decent font size here, you'll notice in this version, we have a beta of a build pack that's really interesting. By the CF build packs. You'll find at the bottom here something that, I remember we said we were playing with doing native. We're doing it outside the platform. Look at this cloud native image, CNB, cloud native build pack, a V3 build pack. And it's sitting there in the platform. And we still have the regular Java one. That's what was running or deployed our app. This new one is coming from the cloud native side of the house, where we took build pack technology and made it portable and made the option that it's baked into Cloud Foundry. That's the V2 level. The V3 level is building typically OCI images that run anywhere you can run an OCI image. But we shimmed it into the platform, which means we can actually have cloud native build pack capabilities, but right back behind the CF push. And so what this one in particular does is it says, okay, if you wanted to use this now, I got to give an app 8 gig and then some and wait 15 minutes. But I can have Cloud Foundry do a native image compilation, run GCC, get us all the way up to a native executable for an application. And I hand it the jar, and it will stage it. Just like it staged the jar with JIT, it'll stage the jar natively. And so that's what's going on behind the scenes. So for me to do that, I have a few switches and flags that I give it more memory. Once it's running, though, we don't need to leave it with 8 gig of RAM. We can do a CF resize and pull it all the way down. We're going to pull it down to 32 meg. So we're going to have that same hello world that we're eating up a gig of RAM with by default, running in 32 megabytes. And to keep this as non-invasive and least disruptive as possible, I'm going to map the new version, which has been parallel deployed non-disruptively against the old one, but I'm going to map it, and we're going to hopefully see our app load balanced across the JIT compiled one and the Graal native image version. And we didn't have to do anything except run a command on the platform to pull this off. And again, early build pack, we're at the hello world side, not going to work for every app, but the idea that we can take the platform and say, hey, try optimizing these workloads. And if they optimize, great. If they don't, no skin. They're running anyway. And so let's go back to the script. So this is the goal, and that's what's cooking. And while I would Martha Stewart this normally, I'll show you guys what the script does, just to make it clear. It's not horribly complicated, because it's really a feature of the platform. And so if we go back up, the hardest part in all of this was something I discovered. I had this idea: could I show off native and not get in Josh or Deshaun's way? Could I say, hey, just do a -p native on that, and I'll see if it works, but just keep working normally, and don't bother setting up a new Graal build environment. Don't bother setting anything. Just keep going at full speed. And so there's a CF curl command hiding in here for me to actually download the app, so I get the GUID for the app. I get the URL out of the metadata v3 apps packages for my app, and then I just pull it into a jar. So I'm able to pull down the jar that was the original thing somebody else could have pushed into the platform. Now I have the jar locally. I'd like to push it again. I'm going to rename the app to be the app name that we originally used, -native. So So it'll deploy like a completely separate app. And then I'm going to tell it about the stack and the build pack and give it 8 gig of RAM. And I'm going to tell it to use a native build profile, active profile. I'm going to tell it to use Java 21. It's got some logging in there. And when that's all said and done and we go to start it, if it starts, we're going to shrink it back down to just an app size of defaulting at 32 meg, and it should be up. So that's the goal. But you'll notice these are just the very basic commands. The thing is, we're going to just let the platform do all the work. And so we are about, where are we? Yeah, we're on our way. We're on our way. So while that's going on, again, it's a beta build pack shim. It's an older build pack, but it's a beta build pack inside Cloud Foundry as a shim. While that's cooking, I'll show you that I did another one. It would be, is it in here? Yes. So here's one that is a REST application, and it's connected to a Postgres instance. And this guy would eat up a gigabyte of RAM. And I did the exact same thing. I ran it to make a native version. This version is running with a Postgres driver, making a REST service out of an entity REST service. And if I go to hit this guy, and it's mapped to both routes, and I can go into /API/customer profiles, and we're seeing a record come out of a Postgres database in an app instance that I only gave 128 megabytes to. And
it's only using like 80 or something, right?
And it's not even it's not even using that much. Yeah, look at that, 79. So
that's not typically.
Think about it. We can take our entity services down by an order of magnitude in footprint. That's mind blowing to me. That means you could run 3 of them if you're worried and still save 70%. So I do truly think there's something here. When you find
just looking at that example right there, you just got a 92% reduction, 92% plus.
Yeah. Yep.
I mean, that's amazing.
I wouldn't dare to run anything using JIT with the memory calculator in less than 768. I think the floor is in the high 6s before it will actually fail to stage.
Yep.
All of a sudden now we're taking these things down and saying, I got an executable. Now, if this is not exactly the same speed as the JIT version, because JIT compilers, that hotspot optimization keeps working. And so this guy will be way smaller and it'll start on a dime. Yep. But if you got something running and it's going to run for a very long period of time, the hotspot compiler doesn't quit. It keeps trying to optimize the most run through pieces of the code path. So I'm not going to get the exact same performance as the JIT compiled one if I let it run for long enough. So we got pros and cons. But when I see that I can take 90% of my memory away, I'm 2 of them. I can, as long as I don't saturate my connections to my connection pool size on the database, we're off to the races. Now look, this guy just finished the original stage that we did. We ran it on the Hello CF Weekly. It's in the process now of shrinking back down from that ephemeral 8 GB image that we needed to stage it. And we should be seeing ourselves coming back down in a minute. If we go back over to the space we were playing in, there's our native one coming along. It's still at 8. It will shrink momentarily. And we should see 2 different GUIDs behind the client. Remember, the client never skipped a beat. The client has been able to invoke the service since the beginning. There's been no blockage, no pause, no outage. There we go. We're now stopping it because it did stage successfully. But 8 GB was only needed to do the compiling part. And so we're close, as we should see this guy come back up again. Excuse the anemic lab. Here we go. Look at this for a size of an app. I think we're going to have to start calling them Pico services.
Yeah.
So, on Boo put up, new instances will come up sooner with auto scaling if you're using this compiling method. 100% true, right? Now, if you take something like this and you do a native image and you look at our auto scaling methods, let's say you've got a RabbitMQ instance that this is tied to, right? So you can auto scale based on queue depth. Now, one of the problems that we've always had with applications, that auto scale based on queue depth up until recently in some of the new releases is that you only scaled by 1 at a time. Well, we fixed that. Now you can scale by multiples at a time. But it always took a long time to get past those queue blocks because it took a long time for those things to scale up. Well, now you can scale up 5 of these instances in less than a second, using both the features that came from Cloud Foundry plus the native image that makes these things boot up quicker. You're going to be able to get past those queue blockages way quicker than you used to in the past. That's huge.
Right. I actually,
not to mention too, that's very important too when you're talking about like forward-facing e-commerce services. When you're getting like a huge spike of traffic, you want those instances up and healthy as soon as possible, right, to keep your SLAs up. So this would also really help there. Yeah,
like you can go. Remember the old the batteries and the ultra capacitors and how some of them charge faster but don't have the same density. You don't have to choose. Like I could run, if I want to leave this going, I'm happy with the JIT compiled version. That's going to be my main. But I need to do burst. Burst is all about reacting as quick as you can. Hey, I might use this guy for the burst. I can pick and choose. If these things both stage and both come up clean with green health checks, then I have 2 scaling levers I can pull. And if I'm proactively scaling, I want to squeeze every ounce of capacity out. Maybe I prefer the hotspot if it's going to run for a very long period of time. But on the flip side, if I want to get the fastest possible start times and squeeze and get the density going, native all the way. If it can support it. What we're trying to do is take away the toil and the headache associated with getting this asset here available to you. And then of course, hey, you know what? That native version is working good enough for me. I'm going to kill this one and take back that gigabyte of memory and give it back to the pool and save some people some money. Boom. And again, our app never stopped.
And let's look at this for services that, going back to the capacity, going to native, you can now fit 12 instances, almost, 12 instances in the same space that you were able to only fit 1, right? So your ability to scale on the platform is greatly increased by this as well. You're able to do more with less, which we all know in the corporate world. That's what you're supposed to do, right? Do more with less, and that's absolutely what you're able to accomplish here.
Right. And so I saw some of the numbers for this, and I said we've got to find a way to make this accessible, to let people try it. And then I started finding out, hey, we're incorporating some V3 build packs into the platform as shims, and I thought, oh, that's very interesting. And by the way, as a shim, it's actually going to sit on top of our existing stack. So it's not like I have to have a Docker registry. This is all fully native to Cloud Foundry. It sits on top of the stacks. We're creating, with Cloud Native Build Pack, a droplet, a special kind of droplet. In this case, it's one that's a native image. Which brings me to the other point. I showed this off to a few folks, and I got some interesting conversation pieces going. First one was, we were sitting here watching on my anemic little home lab for 15 minutes while a native compilation took place. And while no one's going to pretend I got much horsepower in a little nook with 6 cores that's doing all of the work, including running a full vSphere stack in the entire foundation, if it at scale, all your teams and all their pipelines were kicking off 15 to 30-minute compile tasks, that could get pretty noisy. And the platform gives you CPU slices when under contention, proportionate to the amount of memory you get. So these 8 gig or 12 gig container images building these apps are going to start taking a lot of your CPUs. So that brought up the real objection. I can't CF push this to prod. I'd be scared I would eat up the CPU. Now, obviously, you can manage around that. But is there anything we can do? Is there any other feature in the platform to deal with that objection? And this is where the second discovery happened for me this year. And this was one, the native image build pack's new, but this other thing, I didn't even know I could do this. Because this was another one about, could you ever use Cloud Foundry at the edge? And one pushback is, well, we don't want to be compiling containers at the edge. What if you could take your images and just push images? And so I thought, hang on, can you do that? I downloaded the unstaged asset using some APIs for this demo for that little hack script. What about the staged version? Well, it turns out it's natively part of the CF CLI. CF download droplet. So let's do that. So we're going to say that in my lab, let me go into cd/temp, make there z, cdz. Okay. Now, if I look at my apps, I would like that native one, please. All I got to do is CF download droplet. that. And what that will do is that will pull in the droplet, and it'll sit on my machine locally as a tarball. Boom. Now, in the world of prod and somebody else's cluster, and you're not having the room to stage, I've got our colleague Dave Stevenson's cluster here, and I got a space in it, and they're pretty lean with their quotas. I only got 10 GB in this entire org to play with. And we're going to pretend this is a prod environment. We're not supposed to go crazy in here. We would struggle with only 10 GB. We could technically do what we did with an 8 GB push, as long as I wasn't running anything else. But could I get this app running up there without us waiting 20 more minutes to do it? So why don't I just export CF home, USH-temp/c. Okay, fine. So I'm just going to go log in. Bear with me. I'll be right back off screen. Getting a one-time use passcode here.
Well, while he does that, shout out to Deshaun. He must have sensed we were talking about some sweet spring stuff, and he's joined us.
The force is strong with that one.
Yeah.
What did somebody say? Spring?
Foundry Weekly. Spring. I must be here.
Quantum entanglement going on. You can feel the spring force.
Yeah, and I think we're gonna have to have a whole session on just running Cloud Foundry on the edge / running home labs, Cloud Foundry home labs too. So that's I'm gonna have to pencil it in for after Explore. So
well, as soon as you get through with this, I've got some comments because this is bringing up all kinds of ideas in my head.
So look at this. We're targeting prod, right? Somebody else's foundation. CF push. We can call the app what we want. Let's put our native name in here. And oh, I didn't mean to hit return. Let's do it without the return in there. -- droplet. That's it. You can push -- droplet. What? You can do that? So that whole objection that I have to have build packs everywhere, that our foundation, because we do focus so much on the ease of a CF push, then maybe there's times when even a build packless environment could be a very interesting thing to explore, if that's something you specifically don't want to have happening. And there we go. We are now running in the public cloud, not public, in somebody else's foundation. We didn't have the 15-minute Hello World compilation overhead. We only ate 32 megs total ever, including the staging, because this is tiny. And we should be live any second now. There we go. And let it come up. Give it a second more.
That's actually quicker than a normal push because you're not bringing down all the build packs. You're not doing it, even if you separate out the build packs.
There you go.
So here's my thought, Mark. This is where I'm getting excited about this, right? Let's look at companies that are looking to go multi-cloud. Let's look at companies that are looking to do, small foundations, Cloud Foundry on the edge. Here's what I'm envisioning. On-prem or even on cloud, we have a foundation that is used for compilation and build, right? That's what that foundation does. It's not actually providing the URLs anywhere. It becomes a build service. We scope that down to the bare minimum that we need, but it becomes the build service for this. Once the build is done, we download the droplet, we put it in a repo, and now we can go in and we can deploy that to small footprint foundations on the edge, to major foundations out in the cloud. And you're doing this in no time whatsoever. This is something that you could build into a pipeline to do this for you. Right. I don't see any reason why you couldn't.
And remember, imagine an edge environment. Maybe you go into an office or a retail outlet, and you're going to do this. You're going to put in a small Kubernetes cluster, and a Harbor registry, and a vault, and wire them all into each other with some sort of ingress controller. And I could go on and on and on.
Mm-hmm.
I didn't even get to the marketplace, right? I could put a pre-compiled app that could talk to a Postgres. The Postgres can be immutable coming from the marketplace. I don't have to stage the app at the edge. I got all the things that we've talked about, including encryption to container, all that good stuff, just done. Because even though I built an image, a droplet here, I still get sidecar injected Envoy to give me that TLS to the container, just done, hands off. I get the certificate that came in. If I did want to check it, I can look it up because I'll get an XFCC header if they're doing MTLS. There's just so much that's sort of in one box with a bow attached to it that taking away what people thought was a requirement to do the containerization image build at the edge. It's a very interesting tweak to the dynamic that opens this up, in my opinion, because it was discounted for that by some. They didn't want compilation at the edge. Yeah.
Well, and let's even take that a little bit further, right? So, I mean, let's be honest. Let's talk about at the edge. I'm also seeing we push this out to the edge. You got, let's say, Gemfire out there with, a single node, single cluster that is translating your data right there on the edge, but sending it back to a lake or a major database somewhere else. Gemfire can also reduce that data need, and you can have the translation happening there so that you can keep your major database anywhere you want, but the edge can still communicate with it through a simplified Gemfire cluster.
Exactly. Like that idea that you can bring your a shadow store, a cache, data replication fabric, and message queuing, all these things are just sitting there waiting in the wings behind an API gateway. They're all right there. They sit, like I've put this in a Spring Cloud gateway in front of it with a login. In fact, I think I have it here. If I go up here, I wasn't even planning to show that. This is the same stuff we were looking at. But if I do CG secure, yeah. So I get, it would be nice if I actually do it. HTTPS. CG secure. If I could spell, it would work even better. And I think we'll get, so this one's just using an internal login, UAA and stuff. I got to go in, user one. And if I log in, I get through and redirected. And then I have a React app sitting in front of, so I have a Spring Cloud gateway in front of a React front end and that native microservice and Postgres. And it just apps in the space. That's it. And that has no external dependencies. That's 100% platform run, platform managed. You could turn the key to this whole engine and start putting up that. So again, we're scratching the surface. I felt there was something big enough in the difference between running a microservice on a database in 100 meg versus 1 or 2 GB, that there's something magical there. And then when you combine it with droplet portability, which I literally only found out about this year, even though it's been hiding in the feature list for a while. And when you put those two together and you get a very interesting kind of, for me, it was a wow factor at least.
Well, let me ask you a couple more questions on this. So, running your script, the script will go through, it'll get the droplet, it'll convert it, it'll upload it, and it'll create the new droplet on the native image. Now, because it uploads that droplet and basically does a new CF push of it, the only thing that's going to interrupt that output is if a developer comes in and does another CF push. CF restage, CF restart, it's going to keep the same droplet. So the purpose of the script, would you say that this is more like a, hey, developers, we want to prove this out to you. This is what it can do. And then once you prove it out, hey, developers, this is why it's a good thing for you to go in and start doing this yourself? Or is this something that you see being used at scale?
Great question. I thought a lot about this in that we call it an inner loop. When you want to iterate quickly and you want to get feedback on every line of code you want to see did it work? You want to do code test, code build test debug circles. And so native image compiling is not the friend of the person iterating quickly. It is a slow 15 to 30 minute build. It may not even natively compile in some cases. There's some advanced reflection needed. So I feel that you want to JIT compile and even live reload, live debug. We can CF SSH in and remote debug in Taz. We're going to stay in the world of JIT compiling for that. But what I think is very interesting is to have your CI tooling on an async thread trigger an action that would kick off a native image version, and then you can evaluate that in your test harness and make your decision. But you shouldn't have that on the critical path of your development. So I think scaling,
So I think I hear what you're saying, and I like the idea. This is where having that, quote unquote, build foundation comes in. You keep your dev and test exactly the way you've got it. once you've got your code exactly where you want it, you promote that to, preparation foundation or, whatever, which would then run the script, bring out the native image and pass that up for a test before hitting prod. So, if you go, dev test staging prod, maybe now you go dev test staging preparation prod, right?
Yep.
Or you combine it in with the staging, because staging is generally not that utilized. So, having the, maybe you just put that as part of your staging process now.
Or you have an isolation segment with some pretty beefy CPUs and large Diego cells.
Yep.
So that you can keep that off the grid and out of the way, and you can manage it as a platform operator so that no one's ever going to even know you're doing it. And you just start queuing them up into a separate VM / some separate compute. But the goal I was shooting for here was to make it as disruptive as little disruption as possible, because it's not going to work for every app. But my dream state would be that there's a button in the apps manager for my demo, right? And you could just click and it would trigger it. Or there's an agent running, like Josh was thinking, hey, I can use the CF Java API and automate this completely. So you just start looking for apps to try and rejig as native. There's lots of potential for where you could take it. Main thing, your native image, you're never restaging an image that's pushed as a droplet, because I pushed the droplet to the second foundation. You can do all the other operator commands, but you're now getting this. And it's fine, because what it's doing is it's showing that the Cloud Foundry and the Kubernetes, we're building this experience on the other side as well. And we're learning sometimes you don't want to compile the image everywhere. And on the flip side, nobody wants 1,000 lines of YAML to get something working as a responsibility. So can we keep this abstraction and turn it into 5 imperatives that are pretty easy to put anywhere in any tool that you're choosing on an orchestration layer above? That's what we got. Yeah.
I mean, this is, and I'm going to keep beating this dead horse, because I've always been a big fan of small footprint, right? But this is a good use case of small footprint. Mm-hmm. You're not running a foundation. If you use this as a build type of foundation, and we're only going to be creating native images out of it, you're talking, you've got 7 or 8 VMs, before you get to your Diegos. Make those Diegos very beefy CPU, VMs, but you still got very few of them. You don't care about all the rest of the stuff the foundation does. It can be combined in a small footprint. You're really just using the compute power of the Diego cells and the cloud controllers to really make this work. Perfect use for a small footprint foundation.
Yep. I would also say that, like, the conversation about efficiency in Java is, and this is a key, it is one part of the optimization. The first one, and the obvious one, is get yourself to Java 21. Take the 20%, take the 10% or 15% improvement you just get by going there. Then the other thing that we're looking at is this class loader data sharing, which is a kind of a meet me in the middle. It's not going through an extensive compilation down to native, but it's doing some optimizations ahead of time so that we can get a faster start time without it going all the way to native. And so there's a lot of places that you can play to get a better experience in the platform with your Java workloads. But starting the conversation by showing as much as 90% memory savings is a heck of a good one, especially if they're paying for utility rates on the compute underneath.
Or if you're looking to go to public cloud and you want to keep your cloud spend down, right? Huge. This is the way to hyper-converge on hyper-converge.
There you go. That's a soundbite.
Yeah. Yep. We got a question in from Tony, who was also a previous friend of the pod or guest in previous episodes. Stepped away, so I may have missed this, but will the native shim work with custom build packs?
The native shim, there's a native build pack shim. There's a V3, there's a native image build pack that's that's loaded into Cloud Foundry using a shim technique. There's 2 of them. There's static web one and there's this native image one. Honestly, it's early days. I should give a disclaimer here. This is, again, early tech in the Cloud Foundry world. Your VCAP services doesn't get picked up yet by them. So for me to get the database configuration, I did a little bit of a little ugly workaround for where we're at now, where I modified the launch command so I could find out what the database URL was from inside the app. So I basically exported a Spring variable based on what was in VCAP services. it's all in my open repo. Check it out. Again, this is about exploring what we can do to make that next wave of apps run so much better, so much cheaper. Sorry, don't know the full answer though about custom shim build packs though. Sorry.
I would think currently no would be my guess.
Yeah, probably.
But yeah. And then a quick shout out to Keith Lee, who's joining us again.
Hey,
well,
Keith.
yeah, another vote for a home lab episode, I see. Yeah. So maybe we get some Lego in there as well, for sure.
I'll give you one quick teaser for something else I've been playing with. Again, in the efficiency space, there's a framework inside the platform called Spring Cloud Data Flow. I've been playing with it a lot lately. One thing we joke about our platform is a log stream generator that happens to run workloads. We make a lot of logs. There's no blind spots in the platform, but sometimes it can be pretty overwhelming for the ops or for the people paying for the system that's taking all of the logs. You can use the platform itself to create log pre-filters. That's the other thing I've been playing with. Probably a bit out of scope for today, but I want to put a shout out. Sow the seed. You also have a streaming pipes and filter eventing engine that has adapters, so you can tie your platform syslog into a platform hosted syslog listener, and then send it into pipes and transforms and filters and create whatever you need, fit for purpose. And Nick, we've looked at this in other ways in the past. You know, if someone needs a stream that says who's failing to log into this platform for HIPAA, or if someone wants to know where these apps are connecting to, or if they're failing ASG rules that are trying to keep them contained, you can get a fit for purpose stream out of the platform. So again, efficiencies, right? Let's save people money on running the platform, including running the logging systems they might have around it.
So Fynes, I know you talked about, you'd love to see this as a button that was on AppsMan. Have you looked at, is it possible to get this as something that runs as an app on Cloud Foundry, using Cloud Foundry to do Cloud Foundry stuff?
Yeah. The only reason I'm doing this from my laptop at all is just convenience. There's the script itself had almost no requirement. There's no behind the curtain on my workstation been set up to do some crazy stuff. I am running, let's take a look at this bash script. I am running a couple of bash commands. I'm running the CF CLI from the bash script.
Mm-hmm.
And I'm running pretty much that's it. So if I have a modern CF CLI equivalent, whether I use the Java API or whether I actually put a CF CLI into a binary build pack app, I see no reason why I couldn't just pull this all in. In terms of the space, droplets tend to be a bit beefy when they're natively compiled. There's a lot of, frankly, redundant files in there from the staging process that could probably get cleaned out. So I'll need, a GB of disk space. To run the script, I need whatever the script needs to run. It's nothing. The work is all done on the other end of the Cloud Foundry API. So I'm pretty confident we could fit this into something and have it all server-side.
Yeah, this seems like something, we look at things like the CF toolkit, right? CF Butler, those types of things. We look at CF management. It seems like this is something that we could, hey, here's some variables you got to set to make it apply to your foundation. Run this as an app on Cloud Foundry and do this, basically, hey, pass in your app namespace and org where it's sitting and have this happen for you without having to run the script, right? And this brings in that kind of self-help for the developers to say, okay, I want to do this. I just pass it off to this application and it'll do it for me. Yep. I think that's something worth looking into.
Yeah, no, for sure. I'd be very keen to take a look at that because, again, this is about showing off things that are going to get people's attention. And in the way it got my attention, having looked at this for so many years, to see such a, when people go from Java 11 to 21 and they see 10 or 20% better performance, just having upgraded the code, fantastic. Not stunning, not shocking, just a really good outcome. When you can show anybody something 90% better, that's changing the game. That's not an optimization. That's a new way to think. It opens up opportunities like, hey, should I really run one of these, 3 of these, 5? Should I run 9 of them? Should I change my new basic from 3 to 5 because they run in a tenth of the space? You can let the process boundary be the boundary for your workers, whereas you might have been more threaded in the past. It opens up doors for people smarter than myself and much more skilled up at the Spring layers of what this means in terms of how they deploy their app.
Man, I've already got a whole architecture in my head. We're talking to some customers right now specifically about, one, how to reduce cost, how to do things on the edge, how to do portability. Well, Cloud Foundry, that's one of the statements that always comes back. That's not really Cloud Foundry's strong point, right? Is, you got to have all these things for Cloud Foundry to work. Not true. We've got, now we've got what you've just shown, right? Doing the droplet downloads. We've got small footprint that greatly decreases the need for stuff. We've got the idea of a build foundation. This does change the game, and it's definitely going to be talking points that we talk with customers about, because this is bringing a whole new mindset to how we can use Cloud Foundry in ways that, typically we haven't used them in the past.
Exactly.
And especially if you think of like maybe let's say a retail location that needs like a database, a queue.
Yep.
Some apps, like you could all roll that up into kind of one automated deployment, have that all just be fully lifecycle.
And it's literally one. It's like Opsman. And you take a step back and let platform automation do its magic.
Right.
But think about it again. You're going to run Docker, and I've seen it all. I've seen bare metal with Docker Engine. I've seen VMs with Docker Engine. I've seen Kubernetes lightweight. You've seen the imaged VMs. There's no easy answer for the edge when you start thinking about all the things we have just out of the box here.
Yep.
Super.
And one of the primary, kickbacks has always been as well, data on the edge, and how do you do that with Cloud Foundry? Well, we've got an answer for that. That's Gemfire. You can use Gemfire as a one VM solution that will take care of that for you. Especially when we're talking about edge type of traffic going through. Oh man, my head is full of things that we could talk about here.
And I want to leave one thought here. I showed two things that are better together, but they're both independently super valuable. You can do droplet portability for stuff that ain't natively compiled. You can do native compilation where you're running it.
Yep.
Like that whole edge thing may or may not use native. Yep. I think native is great, but hey, maybe I run a Python script. The platform's free to let you pick. Cool.
Yeah, I mean, I've been looking at download droplet for years, never really thought about what it could do. Great demo, Mark. I mean, this is awesome.
Cool. Yeah, I'm glad you guys like it. Yeah. And
so a couple things that we want to show, and again, we will put this down in the show notes, but if you're looking at what he's looking at today, you want to go and kind of look at the Git repo that Mark was showing us. We've got that'll go down in the links as well. And you did the same episode you talked about with Josh Long. So we'll put this down there if you want to go see the same talk, but from a more of a Spring perspective, less from a foundation perspective. Go check out Mark and Fynes on, Josh Long's podcast on Beautiful Podcast. We'll put that link in as well. So, and then lastly, you got questions, reach out to Mark. Here's his LinkedIn page. Man, awesome show, man. Really good stuff. We're going to be talking more about this, Mark.
Awesome.
Yeah. Thank you to all the live listeners and live chat today. We appreciate you being here and joining us. Some of you on a weekly basis. So very thanks to everyone joining. I guess we can't forget to plug our social channels. Please subscribe to our YouTube channel, our LinkedIn, Twitter, whatever you like. But subscribing to our YouTube channel helps our views and our reach. So we really appreciate that. And don't forget about signing up and registering for all those great Explore sessions we mentioned earlier on the show too.
Yeah, because you definitely want to subscribe, folks. You're not getting this information anywhere else. We're the only people bringing you exclusive.
Do we get a badge? If that's a YouTuber thing, I don't know. I probably should know, but yeah. we have stickers, I think. Maybe we need to get new stickers. Did we ever fix the last patch?
No, we didn't. They angered me, so we didn't get new ones. The stickers we got are still out there, but they're not the greatest stickers. We'll eventually get new stickers, but I'm going to go through the 1,000 that we've got before we order some more. But yeah, I mean, Keith, if you want a badge, I've got a deputy dog badge I can send you.
Or I guess we could do what Cote does on their show, and we could mail you stickers, I guess, too. Yeah. So if anyone wants stickers, let us know. We have some to burn through before we reprint.
Tell you what, if you want stickers, then you have to comment on the video. So put some comments in the video.
Yes.
I'll reach out to you. We'll get an address. We'll ship you some stickers, but you got to do some work. We're not giving them away for free here.
And subscribe. Thank you.
And subscribe, right? We'll check. If you're not a subscription, we're not sending you nothing.
Yeah. But anywho, that's the best we got, Keith. I think that's I don't know. Do we have anything else, Mark? All right. Well, thanks for joining the show. And if are we ready to close it out?
We're ready to close it out.
Well,
Anbu's in the audience, so
yeah,
he can
give
say
a shout out. Yeah.
Yep. All right, everybody. We'll see you next Thursday.
All right. CF bye.
CF bye.
CF bye.